Python's Level 1 track builds the foundation everything else stands on, and this video walks through 5 of its 10 modules back to back, the sequence that takes you from knowing nothing to writing real, working scripts. We'll cover variables and operators, control flow, functions and scope, core data structures, and error handling, each one building directly on the last, so stick with the order even if one topic feels familiar already. Every Python program starts with data living in variables. Let's look at how Python names things, what its core building block types are, and the operators you'll reach for constantly. In Python, a variable is just a name pointing at a value. There's no type declaration to write first. Here we bind age, name, height, and is_student in 4 lines, and Python figures out the type from what's on the right. Notice there's no var, let, or type keyword anywhere. The name and the value are all Python needs. Under the hood, everything falls into one of 5 core types: whole numbers, decimals, text, true or false booleans, and none for nothing here. Calling type on any value tells you exactly which one you're holding. Python gives you the usual arithmetic operators, +2 worth memorizing, / for floor division, which always rounds down to a whole number, and % for the remainder left over after dividing. Regular division with a single slash always gives you a float back. Comparisons give you booleans back, and it's worth noting == checks value while is checks identity 5 and 5.0 are equal in value but not the same object. Combine comparisons with and, or, and not to build up conditions. With variables, types, and operators down, you're ready to make decisions with that data, which is exactly what control flow is for. Control flow is how a program branches and repeats if/else decisions, loops that run while a condition holds or over each item in a collection, and Python's newer match statement for cleaner multi-way branching. Here a score of 82 falls through the first check, matches the second, and grade becomes B. Python checks each condition top to bottom and stops at the first one that's true. A while loop keeps running as long as its condition holds. This one prints 0 through 4, incrementing count each pass, and stops the moment count reaches 5. Python's for loop iterates directly over a sequence rather than counting indexes. You can loop over a list of values directly, or use range for numeric sequences including a start, stop, and step if you need to skip numbers. Break exits a loop early once you've found what you need, continue skips just the current iteration, and the lesser-known loop else clause runs only if the loop finished without ever hitting break, handy for search patterns like this one. Once your code can decide and repeat, the next question is how to package that logic into reusable pieces. Functions. Functions let you name a chunk of logic and reuse it. This module covers defining them, documenting intent with type hints, flexible argument patterns, and how Python looks up names through scope. A function is defined with def, a name, and parameters. Giving greet a default value for name means you can call it with no arguments at all, or override that default whenever you want. Args collects any number of positional arguments into a tuple, so total can sum however many numbers you throw at it. *quargs does the same for keyword arguments, gathering them into a dictionary. Notice both functions carry type hints to int for totals inputs, str for the profile's value, so your editor can flag a mismatch before you ever run the code. You can also force how arguments get passed. The star before timeout means it must always be named, while the slash after A and B means those two must be passed positionally, no keywords allowed. Python resolves a name by checking local scope first, then any enclosing function, then global, then built-ins, that's legb. Each nested function here has its own x, so printing it at each level gives a different answer. With functions handling behavior, the next piece is organizing the data they operate on. Python's core data structures. Almost every Python program leans on 4 built-in containers: lists, tuples, dictionaries, and sets. Picking the right one makes your code both clearer and faster. Lists are ordered and mutable. You can append, insert, remove, and pop items, index from the front or the back with negative numbers, and slice out a range. That last line, a list comprehension, builds a new list from an expression in a single readable line. Tuples look similar but can't be changed after creation. That immutability is actually a feature. It means a tuple can be unpacked into separate variables, and even used as a dictionary key, which a list never can. Dictionaries store key-value pairs and give you constant time lookup by key. Using get with a default avoids crashing on a missing key, and .items lets you loop over both keys and values together. That comprehension on the last line works the same way for dictionaries as it does for lists. Build the whole thing from one expression instead of a loop and a bunch of appends. Sets hold only unique items and support real math-style operations: union, intersection, and difference, plus a very fast membership check within. Reach for a set whenever you need uniqueness or quick lookups, not order. You now have data organized and logic to process it, but real programs also need to handle things going wrong, which brings us to error handling. Things go wrong in every real program: bad input, missing files, network hiccups. Python's try and accept blocks let you handle those failures gracefully instead of crashing. Wrap risky code in a try block, and if it raises an exception, the matching accept block catches it instead of the whole program crashing. Here, dividing by 0 triggers 0 division error and we handle it cleanly. Always catch the narrowest exception type you can. A bare except hides real bugs. This safe_int function only catches value error, so converting ABC fails gracefully while a genuinely unexpected error would still surface. 2 more clauses round out the picture: else runs only when nothing went wrong, and finally runs every single time. Success or failure perfect for cleanup code like closing a connection. You're not limited to exceptions Python raises for you. Raise your own when a rule in your business logic gets broken, like this withdraw function refusing to overdraw an account. The caller catches it exactly like any built-in exception. That's the full arc: variables and types, decisions and loops, functions and scope, data structures, and now graceful error handling, everything Level 1 sets out to teach. That's the whole Level 1 arc in one sitting: variables and types, control flow, functions and scope, core data structures, and error handling. Every one of those 5 modules has runnable code and a hands-on exercise waiting on the site, plus 5 more modules we didn't have time for here: setup, strings, and formatting, file I/O, modules and packages, and the capstone to-do app project, which ties everything together into one real command line tool. If you followed along this far, you already have everything you need to start writing genuine Python scripts today. The links to every lesson we covered, in order, are listed below, along with the full Level 1 index if you want to pick up the modules we skipped.